a bad idea to do like a rough sketch of a triangle, so you can kind of have an idea of where the sides and angles will fall. Okay, so we're doing number 10 here. And another thing, we use capital letters for angles and small letters for the sides. So that's how you know what you are given. So when they're giving you capital A is 24.3 degrees, that's this angle right here. C is 54.6 degrees. And then side C is 2.68 units. So of course the idea is then we need to find angle B and we need to find what the measurement of sides A and B is going to be. So any idea how we can find that angle B? If you're given two of your other angle measurements, what can we do?
Oh, subtract from 180?
Yeah, because we know all three angles inside a triangle should add up to 180. So to find angle B, you're just going to take 180 degrees and subtract the other two angles from it. That's of course 24.3 for angle A, 54.6 for angle C. So what do you think that subtraction will end up giving us?
Oh, sorry, my calculator is in a different version, so it's 101.1 degrees.
Very good. Yeah, 101.1 degrees. So in this case, finding that third angle is of course very straightforward. Okay, so now once we get down to finding sides A and B, this is of course where our law of sines is going to come into play.
So then do you just put that angle over sine of, or that side length that you're trying to find over sine of whatever the degree
That angle
is?
would be, yeah.
Yeah, okay.
So let's say we start by finding side A. So for side A, we can do A over sine of angle A. And in this case, since we are given side C and angle C, we're going to set this equal to side C on the top and then sine of C on the bottom. Now, of course, we're trying to find side A. We already know what angle A is, so I'm actually going to go ahead and multiply both sides by our sine of A so that we can get that side A by itself.
Mm-hmm.
A equals C over sine of C multiplied by sine of A. And of course, our side C is 2.68 units. Sine of angle C was 54.6 degrees. And sine of angle A would be 24.3 degrees. And you can literally just enter this in your calculator and get a decimal approximation. Just make sure your calculator is in degree mode. And if your calculator does parentheses, then just make sure you're opening and closing parentheses accordingly.
I got 1.35.
Okay, so that's rounded to 2 decimal places. 1.35 looks good. Yeah, that's what I got. Alrighty. So this would be for side A. All right, so in that same way, you will go ahead and find side B, but again, I would actually take side B and set it equal to C and sine of C, just because those were our given numbers, so that will avoid any approximation errors, because, you know, of course, side A is an approximate answer, so that will affect your calculation for side B. So just go ahead and set it up again, and let me see what answers you guys come up with. So what do you have?
Wait, that's okay.
Were you able to come up with something?
3.13.
3.13.
That's
That's not right.
Did you do one? Did you use that? If you did, that's for A.
You're off just by a little bit.
Ooh. What'd you do?
I've got this. Is it 3.223?
Yeah, 3.23. So what happened the first time around?
When I punched it in the calculator wrong. I just did 2.6 instead of 2.68.
Oh, I see. Okay, okay.
Yeah, so then it got me like so close, but not quite there because I was
Not
missing a
quite
point.
there.
Oh,
Yeah. All right, very good. So yeah, it is 3.23. And so basically you can see as long as you are given the two angles and one of the sides, of course, finding the third angle is going to be straightforward. Just subtract both angles from 180 degrees. And then for finding the two missing sides, you can use your law of sines for that. Now, another form of that same angle could be something like number 14, where they're actually giving you sides A and B, but instead of giving you a side opposite to one of those angles, they're giving you a side opposite to the missing angle. But in this case, again, the same thing would be, you would take your 120 degrees and 45 degrees, subtract that from 180, you get your angle C, and then of course using side C, you can do the same calculation. So just a different variation of the same problem we looked at. But what I want to look at next is actually right here, number 18, where you are actually given one angle and two of the sides. So let's take a look at number 18 over here. Angle A is given to us as 60 degrees. Side A is 9 units, and side C is 7 units. Okay, so obviously we're not quite ready to find our missing angles over here. So where do you think we can start? Because if we're given side A, angle A, we are given side C, where can we go from there?
Take 60 degrees, subtract it from 180 and divide by 2. Would that be it?
No, we cannot make the assumption that the remaining two angles are going to be the same measurement.
Mhm.
Because if that were true, then shouldn't all three sides have had the same measurement? Because you're basically talking
Oh,
about
that's true, yeah.
equilateral triangle. Yeah. So what's going to happen here actually, like I was saying, since we are given side A, we are given angle A, we are given side C. So based on this information, we can actually find angle C next. So that's where you want to head. So let me get rid of this. So you will basically, since we're finding angle C, you want to put the sine of C on the top, side C on the bottom, and then sine of A on the top and side A on the bottom. So to get angle C, of course, we want to isolate sine C first. So we can go ahead and multiply both sides by the small c. And you will end up getting sine of C equals sine of A. A is 60 degrees. Side A is 9 units. And side C is 7 units. So again, we can put this in our calculator, or even for sine 60, you can also use your unit circle.
Sound good.
And are we getting, what is the answer that we're getting?
Oh, wait, we're finding the angle?
We are finding the angle. So right now you're just solving that right
Okay.
side, which will end up giving you
67 point, or not 67, 0.67 is what I
yeah,
got.
and it's a whole bunch of numbers after that, right?
Mm-hmm.
What are we going to do to get angle C? Because right now the answer we got on our calculator is for sine C, which is equal to that whole big number. Now what do we do to get C by itself?
Arc sine.
Yeah, very good. You have to use arc sine on this whole number.
That comes out to 42.34.
Yeah, and we're still doing the two rounding decimal places. So you said 42.34?
Yep.
Okay, and this will of course be in degrees. Okay, now what can we do to find the next angle?
Subtract by 180.
Yeah, now you can do the subtraction since we have two of the angles.
Oh, that comes out to 77.66.
77.66 degrees. All right, very good. Now what can we do to find our side B?
Use the same thing that we did last time.
Yeah, so again, I would use, since angle A and side A were given to us, I would again set it equal to those two values. And this time you are finding side B. So B will go on the top, sine of B on the bottom, and then set it equal to A over sine of A. And again, of course, we want to move that sine B to the other side. So let me see what answer you guys get for side B.
I got 10.15.
10.15, okay. And that's again two decimal places. Alrighty, 10.15 for side B. Any questions on this one?
Nope.
Okay, so just two different ways of how we can come up with, based on what information that's given to us. So like you can see in this case, we just inverted our law of sines by putting the angles on the top so that we could go ahead and find angle C. And then of course, we repeated the process of finding angle B by subtracting those two and then finding side B based on that. Alrighty. Now, the next set of examples I actually want to look at is where we get into, if you look through your handout, we talk about the ambiguous cases in here. So let me pull that up. And this happens when you are given two sides and one angle. So in this case, as you will see, we talk about three possibilities that occur. You can actually end up with no triangle because no triangle would be able to satisfy the conditions you were given. You could come up with one triangle which would satisfy, or you can also actually come up with two different triangles which would also satisfy those conditions. So for the ambiguous case, it actually depends on what we are given. So you can see the first few triangles we're talking about is where our angle A is an acute angle. And then H, of course, represents the height of our triangle. So they are saying if side A is going to be a value less than the height of the triangle, then you will actually come up with no triangle at all. Now, the same thing can happen if you have A as an obtuse angle. And in this case, if the value of A is less than, or for that matter, even equal to B, that is a second case where you may end up with no triangle at all. So those would be the two cases where we get no triangles. If the value of A is equal to the height of the triangle, you will come up with one distinct triangle. If side A is greater or equal to, you can again come up with one triangle. For an obtuse angle, if your side A is longer than side B, then again you get one single triangle. The only case where you get two distinct triangles is where the height of your triangle is less than side A, and both of those numbers are less than side B. In that case, you end up with two distinct triangles. So when we go through these examples, those would be kind of the things we need to look for. And then they're actually giving you how to calculate the height of your triangle right here. It says H equals B times sine of A. And you know, they're basically using the sine function to come up with this. If this is your angle A right over here, then H is the opposite side, B is the hypotenuse. So you're doing opposite over hypotenuse. And then just to get H by itself, you go ahead and multiply B on the other side. And you get this definition of H equals B times sine of A. So in some examples, we'll actually calculate that to see if one of these conditions is true, and then based on that, we will know how many triangles we can come up with. So we're starting out with number 24 here. So the instructions are use law of sines to solve for the triangle if it's possible. If two solutions exist, found both, and of course round your answer 2 decimal places. So we're starting out with number 24 here. They're giving us one angle and two sides. So 110 degrees for angle A, 125 and 200 for angle B. Okay, so first of all, is this acute or obtuse?
Obtuse.
Obtuse, very good. So if it's an obtuse angle A, that means we're looking at these last two cases over here. And they're saying if the value of A is less than or equal to B, we have no triangle. If A is greater than B, then we can find one. So what situation are we looking at?
A is less than B.
A is less
So
than.
there's no triangle.
Yeah, there you go. So you actually have no calculation to even worry about here because the value of A being less than B, because you know, of course, if you think of this as an obtuse triangle, this is our angle A, then the side opposite to A has to be longer. Let's say if this is angle B, has to be longer than B, right? But if this guy is smaller, then it's not even going all the way to the edge of that triangle. So that's basically what's happening. So that's why you have no triangle and there's no solution to this. Does that kind of make sense?
Yeah.
Are both of you okay? Adrian, are you okay?
Oh, yeah, I'm fine.
Okay, right. So that was number 24. Yeah, on that same part, let's look at number 26 over here. So we're given A as 76 degrees. Side A is 34, side B is 21. So this is an angle which will be acute, obtuse,
You.
acute. Okay, and of course you can see here, A is going to be greater than B. So let's take a look. Oops, not this one. Okay,
Where we
so
have one triangle.
yeah, we should have one triangle because that's that third case that we are looking at. So let's go ahead and see how we can go about solving this guy. So we are given angle A, side B, and just a rough sketch for our triangle. What can we find next?
Angle B.
Yeah, we can find angle B. Very good. So for angle B, you want to put sine of B on the top, side B on the bottom, which again will just basically end up multiplying that side B, move it to the other side. Okay, so let's see, sine of angle A is 76 degrees. Side A is 34. Side B is 21. And what will this guy end up giving us?
Oh, I gotta pick the project. Oh, that's what I got a big number. I don't know what it is.
Okay, can you
I
describe
got like
what it is?
700 and something. I don't know.
Oh boy, no.
Yeah.
Did you try typing all of this at once?
No, I broke it up into two parts.
Okay, so you
I did
started
34 over sine of 76 and by 21. I don't know why it's coming out that weird number. Let me try it again. Got a smaller number.
I don't know if it was just a matter of parentheses or something. Because if you just do the right-hand side, sine of 76 degrees divided by 34 times 21, you should
Oh,
get...
that's why. Okay. I see why you did it wrong.
Oh, okay.
Thank you. We're trying to find the degree, right?
Degree, yeah.
Okay, so then we need to multiply by, or yeah, multiply by the arc sine.
Yes.
Okay, so 36.81.
Yeah, I thought when
Or
you
82,
ran-
sorry. 82.
Yeah, that's what I had, 36.82. $36.82. Okay, so angle C will be what?
36.82 minus 76. Um, 67.18.
67.18 sounds good. Alrighty. And that leaves us with
finding the side of C.
Yeah, finding side of C. So in this case, again, I would use angle A and side A because they were our given values. So for finding side C, we'll of course put C on the top, sine of C on the bottom, and then A on the top, sine of A, which of course will end up multiplying both sides by sine of C. And that would be 34 over sine of 76 degrees multiplied by sine of 67.18.
Yeah, 32.2 or 0.30.
Okay, 32.30 sounds good. And this is, of course, side C. And you know, the basic rule of thumb is across from the largest angle, you would have the longest side, just like we saw with our right triangle, right? So that's going to be the
Mm-hmm.
6 is the largest angle we have here. So that means 34 would be the longest side. And then, of course, from the smallest angle, you would have the smallest, across from that, the smallest length. So that also kind of helps you keep track of your calculations. Okay, so this was the example where you had only one single case coming from the acute angle. So any questions on this one?
Nope.
Nope, okay. So let's see the next one that I wanted to look at. Okay, is number 28 here. So 58 degrees for angle A, side A is 4.5, side B is 12.8. So of course, this is again, angle A is acute. And side A is smaller than
Yeah.
side B. Okay, so in acute angle, there's really nothing about A being smaller than B per se.
No.
Let's actually go ahead and talk about the height of our triangle then. So that's going to be H equals B times sine of A. So B, of course, is 12.8. Sine of A would be sine of 58 degrees. So what does that come out to be?
10.85 or 86 then.
All right, 10.86. So comparing this to side A, which is 4.5, A is still smaller than H.
Mm-hmm.
Okay, so let's see now in acute angle, they're telling us if A is less than H, which means you again have no triangle. Because as you can see, again, that side A does not reach all the way to the bottom of our, it's not going to meet the vertex. That height is going to, that length is going to fall short. So we will have no triangle, which will satisfy this condition. So basically you have a triangle that gets halfway or somewhere in there and you're not coming all the way down. So basically with obtuse triangles, A cannot be basically less than B, right? Because that's when we don't have a triangle. And then with acute angles, the side A cannot be less than what the height of the triangle should be, because again, we have no triangle in this case. So that was number 28. Now, the next example I actually want to look at is where we will talk about having potentially two different cases. We are looking at number 32 over here. So how can we go ahead and rewrite that angle A?
You could just do 25. 25.06 is what I got. Is that right?
Yeah, because did you use your calculator or did you use like division by 60?
I just used my calculator.
You just use your calculator, okay. Yeah, so 25 approximately 0.7.
Yeah.
Okay. So obviously we're looking at an acute angle over here. What will be the height of this triangle?
B sine. Right. Oh, it's just a minute. So good. Well, 9.32.
Yeah, we barely make it, right? So
Mm-hmm.
we can say
Oof.
A is greater than H, which means this is going to work in our favor. So if A is larger than H, or basically H is smaller than A and A is smaller than B, then we can end up getting two different triangles for this. So that's actually where we are at, because obviously you can see 22, the value for B is the greatest one. So H is smaller than A and A is smaller than B. So we will end up with two different triangles. So let's see how we can go about doing this. So we're given angle A, we're given side A and side B. So where can we start?
Finding side B.
You mean angle B?
Yeah, sorry.
Okay, yeah, that's exactly where you want to start. So start by finding the angle B. So that would be, again, multiply B on both sides, get that sine of B by itself. 25.07 degrees sine of that. A is 9.5. B is 22.
Okay, I wound up with 78.89.
Okay, 78.89 looks good. And that would be for angle B, right?
Mm-hmm.
Okay. Now, basically what happens here is if you actually just, let me show you something. Okay, so if you just did the right-hand side and left that sine B as it is, you would actually get 0.8486 just as a rounded off answer. So since this number is less than 1, because remember the range of the sine function is negative to positive 1. So as long as the value is basically in this case less than 1, that means we can actually find angles in both quadrant 1 and quadrant 2. So that's actually what creates these two different triangles. So I'm actually going to call this one as angle B1 for the first triangle. And then to find the second angle for B2, you can actually just take 180 degrees minus this angle you just found, 78.89. And when you subtract that, you will of course get your second B angle, which will come out to be what?
101.11.
Yeah, very good. So this is going to create two different situations for us. So here we will use the acute angle, and then using this we can find side C and angle C. And then for the second triangle, we'll use the larger, the obtuse angle, and using that we again will calculate side C and angle C. So that's how you actually end up with two different cases. Alrighty, so let's take a look here. We've got, okay, let's put it down here. So to find, and again, you can start by angle C. In this case, we have 180 degrees. Subtract angle A and B1 from this guy. And on the other
What was angle A again?
it was 25.07.
Oh, yeah. For angle B2, I got 53.82.
B2.
B2, yeah.
Okay, and for B1,
I got 76.04.
76.04. Okay. Oh, hold on, I put this incorrect here. This should be 101.11.
Mm-hmm.
You tell me that decimal value again?
0.82.
0.8. All right, so now that we have our angle C, now we just need to find the side C. That would be side C over sine of C. And again, since values A and angle A were given to us, that's what we're going to set these equal to.
Mm-hmm.
Side A was given to us as 9.5. Sine 5.07. And angle C here was 76.04. Okay, so for angle C, where you had 76.04, what's your side C calculation?
I got 21.76.
Alrighty, very good. 21.76. And for the 5382 angle,
Sine of 18.1, or yeah, 18.1.
Yeah, very good. Alrighty, so this one here will basically be an acute angle. This one here is going to end up being
Yes.
an obtuse angle. We had 25.07. This guy here was 78.89. And then this one was 76.04. And of course, this guy was still 25.07, but angle B was the 101.11. C, of course, was just your 53.82. So two distinct triangles, and like I was telling you before, that's coming up from the idea that sine of B can basically potentially give you quadrant 1 and quadrant 2, because these values will be anywhere from 0 to pi. And that's, of course, because this value came out to be less than 1. So we're still within the range of the sine function. So that's why you actually end up getting these two different options. And then based on that, you have to do two different calculations for angle C and side C. So any questions on this example over here?
Nope.
You guys okay on that?
Yeah.
Alrighty, very good. Okay, this one is just to talk about the area of our triangle, and in this case, we're rounding it just to 1 decimal place. Let's look at number 40 over here.
Number are we looking at?
40.
Oh, 40.
And this is actually coming from right here. They actually have a different version of your area of an oblique triangle depending on which measurements are given to you. So if you're given, which is our case, angle A and sides B and C, then you're of course using this first form. But just depending on, if you look at number 41, you are given angle C and sides A and B, so you would actually just use this version of your area formula. So they just kind of keep changing it up based on what angle and which sides you are given, but they will all obviously get you the same result for the area of our triangles. Of course, for number 40, we're just using that first part over here. So let's go ahead and take a look at that. We are given angle A as 72 degrees, side B is 31 units, and side C is 44 units. So area is going to be 1/2 B times C multiplied by sine of A. And you know, the easiest way to remember is if they're giving you angle A, then you won't have side A, you will have the other two sides, B and C. If they give you angle B, then you will have sides A and C. If they give you angle C, then you will have sides A and B. So it's always going to be all three of those basically alphabets in there, but whatever is the angle, the sides will be the other two. So it's a neat way to remember what formula you need to use. Okay, so plug your numbers in and let me see what answer you come up with.
648 units, or 648.6 units squared.
Yeah, it would be, since we're talking area, it would be units squared. And this one was just asking us to go to 1 decimal place. So 648.6 square units. I'm kind of surprised that they are not including any kind of units in any of these examples.
Weirdos.
Yeah, very unusual for a math textbook to do that. So, I mean, as you can see, as long as you're following that formula, you guys should be okay. But did you have any question on this one?
Yeah.
So I did want to look at just a couple application problems here just to show you how these are used. So we are looking at, let's make this kind of smaller, number 48 over here. So they're saying a bridge is built across a small lake from a gazebo to a dock. The bearing from the gazebo to the dock is southwest 41 degrees. Now remember, your bearings are always going to be with respect to that vertical line. So your bearings are always with respect to these vertical lines. That's why this angle here is your 41 degrees. And then they are telling us from a tree, 100 meters from the gazebo, the bearings to the gazebo and the dock are 74 degrees southeast. So again, remember, they're still talking bearing, which means we're talking with respect to this vertical line. This angle is 74 degrees, and the angle with the dock is 28 degrees southeast. And they're basically asking us to find the distance from the gazebo to the dock. So they're of course asking us to find this distance over here. So you are given angle 41 over here, which is between the vertical north-south line and that bridge that's built. So you are also given the bigger angle over here near the tree, which is 74 degrees, and the smaller angle is 28. So using that information, do you know what this angle will be here? Which is between the line that goes to the dock and the line that goes to the gazebo from the tree?
The line in between them? Or,
So inside the triangle.
oh, inside the triangle?
Yeah, so if you, I don't know, I guess we can call this point D or angle D. For gazebo, we'll call it G, and for tree, we'll call it T. So we're basically inside the triangle trying to find what that angle T is going to be.
Okay, so just 28 plus 74,
So if this is
which is 102 degrees.
no. I'm asking you to find this.
Oh, it's just 74.
This is 100 meters. They're asking us to find this distance. So the bigger angle, oh, hold on a second.
What the heck?
Yeah, it's trying to kick me out of the textbook. It's like you've been here too long. Okay, let me change some colors over here. So this bigger angle is 74 degrees. This smaller angle is 28 degrees. And I'm asking you to find this angle here inside the triangle. So if the bigger angle here is 74.
Oh, okay, I get it. Okay. The image is misleading for me, I guess.
So what would this be?
Um, 46.
46 degrees. Yeah, that's what I'm looking for. Okay, 46 degrees on the inside. Okay, now do you know how that information of 41 degrees can help us out?
Shouldn't, gosh. God. Google will use this.
Okay, let's look at the gazebo side over here. I'm gonna erase this guy for now. Okay, so this is the vertical line that our north and south is making. This is somewhere over here is our gazebo. Now, this is the bridge that's going towards the dock. This is the line that's going towards the tree. They're telling us this angle here is 41 degrees. I have another vertical line from the tree going here, and we are saying this angle to the dock is 46 degrees. So if this angle here is 41, this angle here is 46, anything ringing a bell in terms of geometry?
The top on the other side. Should the top on the other side be 46 degrees as well then? Is that what the...
This guy here?
Yeah.
Yeah, because these would be, no, sorry, it would not be 46. It will actually be that bigger angle. Oh.
Oh, okay. So it'll be the 74.
Yeah, because this one actually is the awkward line, but this whole thing was 74 degrees. So this guy here would actually be 74 also.
So would that G angle be 64 degrees?
Yeah, and that's what we're trying to find. Actually, I got 65.
Yep, 65.
Okay, very good. So this, yeah, that angle is 65 degrees. So, okay, so if that guy is 65, what is
And then we
this?
can use 180 to solve for the other angle.
Very good.
Is it 69 degrees?
It will be 69 degrees. Very good. So 69 degrees for that dock angle. Okay, so now that we have all our angle measurements here, we are given this side, I guess, D, which is 100 meters. Now they're asking us to find the distance between the gazebo and the dock. This distance here, so what measurement can we use for that?
Well, we use the 46 degrees from the inside of the triangle on side T, and then that's our missing side. And then we use the dock angle and the 100 meters on the other side.
Yeah, because those would be our given information. Now let me see if I can kind of use this here. This is a mess, but let me try and get us an image over here. Yeah, so basically now we have our triangle sort of to help us out. This is our dock, gazebo, and tree. We know this distance is 100 meters. This angle is 46 degrees. This one is 65 degrees, and this is 69. And you're basically finding side T. So you were saying we're basically setting this up as T over sine of T. Is that what you were saying?
Yeah.
And then set it equal to basically side D over sine of D. You're multiplying 100 divided by sine of 69 and multiply by sine of 46.
Yeah.
Yeah, that's the right setup. Yeah, very good. So once you simplify that, and they didn't tell us really anything about rounding, but since we are doing this as an application, we'll go ahead and round it to a whole number.
I got 77.05.
Yeah, 77.05. So you
So
can just round
77
that to 77, and that will be our approximate, basically, length of the bridge, right?
Mm-hmm.
So yeah, very good. 77 meters. All right, nicely done. Any question on any of that?
Nope.
No.
Okay, both of you are okay?
Yep.
Alrighty, very good. So yeah, I mean, most of your applications are going to be, something like this. As you can see, we had to go through quite a few calculations just to even come up with our angle measurement. Some of them may be a little bit more straightforward. Some of them will probably be something what you saw over here. But any questions about anything we've done so far in 3.1?
Nope.
Nope, you're okay?
Yeah, we're okay.
All right, I will open up this homework either today or tomorrow. I am actually still trying to wrap up everything from the exams and stuff everybody's done in all my classes. So I'll go ahead and open that up, like I said, either today or tomorrow. So just kind of keep looking for it. And then we'll do 3.2 on Thursday. Now, normally we have combined chapter 3 and chapter 4 exams together. So chapter 4 will probably take us all of next week and maybe an additional day. I'm not sure. We'll just have to see what pace we keep up with. So I'll go ahead and open up quizzes for chapter 3 also, but your exam will be after we finish chapter 4.
Okay.
Okay. All right, guys. If you have no questions for me, then that's it for today.
Alrighty. Thank you,
Alright,
Ms. Durga.
You too.
Bye.
Take care. Be careful, guys. Bye-bye.